So we start with 7.1 does systems of equations using substitution and graphing. And then 7.2 is elimination. So that's usually, I would say, if you could choose, a lot of people choose elimination, but we're going to pretend like we don't know it yet. And we're going to practice these two methods, okay? So system of linear equations are two linear equations that have two variables. So you're talking about two equations with an x and a y. Linear would be both lines. You will also get to the point in which they are a linear mixed with a parabola. So it could be a line and a parabola. It could be a line and a circle. It could be two parabolas, right? We're going to start to see stuff like that as well. But when we're solving, we start with just two linear equations, okay? The ordered pair is what satisfies both equations in each system. So my answer is going to be an XY combination. That XY combination should be able to be plugged into both equations and give you a true statement. That's how you know it would be the solution. So the first example is literally just showing that you can check every single systems of equation by working backwards. Should this be a standardized test and you have systems of equations and you forget how to actually solve them, but you have multiple choice answers, you could literally plug them in. Sometimes it's more work to plug in into both, but you have that option. So this one says determine if -1, 3 is a solution to the system. In order for it to be a solution, it has to get plugged into both. So 2 times -1 minus 3 would be -5. -2 minus 3 equals -5. And -5 equals -5. So it works for that one. Then you got to do the next one. So x plus y equals 2. -1 plus 3 equals 2. And 2 equals 2. And it works for that one as well. The answer to this would be yes. If it worked for one, not the other, it's no. Obviously, if it works for neither, it is also no. Good so far. All right, so finding a solution from the graph, we're going to learn to either see a graph and find the solution from it, or graph from scratch and then find the solution from it. The solution of a system of linear equations can sometimes be found by graphing both of the equations in the same rectangular coordinate system. And then for a system with one solution, the coordinates of the point of the intersection give the system solution. So where they intersect would be the coordinate. So this one would be like 4, -1, would be your solution to the system. If you had a line and a parabola, let's say, you might have two solutions in which they intersect, okay? If you had a line and a circle, could be one solution, two solutions. Could be no solutions if they don't intersect, which we'll get to in a little bit. To solve using substitution, which is going to be the first method we're going to practice, it says to solve one equation for one of the variables. So you can pick either equation and either variable. You're going to solve for that one. Then you plug that expression into the second equation in place of that variable. You'll only have one variable left, so you'll solve for it. And then you'll plug that value back into either equation to solve for the remaining variable. Special cases with these. The first is if the variables cancel and you are left with a true statement. Like 1 equals 1 or 0 equals 0, right? Those would be true statements with no variables. This solution is all real numbers. I think, let me check what I was saying. It sometimes says infinitely many solutions. Sometimes it says literally like the words all real numbers. I'm forgetting what I was saying, so I'm checking it now. If you're taking a quiz or a test from me and you wanted to give that answer, you could literally write all real numbers. You could write the fancy R like that, which means all real numbers. The second special case is if the variables cancel out again. And what's left is a false statement. something like 1 equals 0. Obviously not a true statement. And in that case, it is no solution. Again, if you're writing it like on a test or a quiz, you could put NS, you could put 0 with a strike through. That means the same thing. I'm checking WebAssign right now. All right, so notice directions this time say solve by substitution method. If it gives you the specific method to use, you need to use it. If it just says solve, you get to choose. But for right now, we're going to practice substitution. So I'm going to look at both equations. You want to kind of plan 2 steps ahead. Look at these equations and say which of these is going to be the easiest variable for me to get by itself in either equation. So look at all, there's 4 variables there, right? Look at all of them. Which one's going to be the easiest to get by itself? The y in the top. So I'm going to move the 5x to the other side. So y equals 9 minus 5x. Sometimes there's a variable by itself like that. That's easy. Sometimes you can't avoid the moving and dividing, and you're just going to have to do it, okay? So now I take that y equals whatever it equals, and I plug it into the other equation in place of the y. So I get negative x plus 3 parentheses 9 minus 5x equals 11. I'm going to distribute negative x plus 27 minus 15x equals 11. Negative 16x plus 27 equals 11. And then I would subtract 27 from both sides. Negative 16x equals negative 16. Divide by negative 16. And x equals 1. So that's the first part of my solution. 1, and it's the x, so it goes where the x goes. To find the y, I can take and plug that back into any equation into that variable. So you might look again back and say, well, this one's already solved for y. I'm going to take it and plug it right back in there. Y would equal 9 minus 5, y would equal 4. But if you choose something else, it doesn't matter. No matter where you plug that 1 in, if it's the correct answer, it would get you the same value for y. Okay, then you're going to get decimals, you're going to get fractions, right? So obviously I would go through every way you could possibly to get rid of those things. If it's a fraction, I'm going to multiply the least common denominator to get rid of it. If it's a decimal, you can multiply by powers of 10 to get rid of them. If you want to leave the decimal, you can too, but obviously mistakes usually get made with silly stuff like that. So if I have 1 digit behind each of these decimal places, I would have to multiply the whole thing by what to get rid of it? 10, good. So I get 15x plus 8y equals 23. And then go to the second one. Again, I have 1 digit behind them. I can multiply by 10 again. You can multiply 1 by 100 and 1 by 10. It doesn't matter as long as you get rid of it. Just to get rid of the decimal. You don't have to. Are you going to say again? No. Yeah.
So on the test, are we going to have to do substitution, or can we do like elimination?
It's going to tell you specifically to do some, and it's going to give you the free reins to do whatever on others. Yeah.
If you multiply by 10 for the first one, you have to do it for the second.
No, you could do 10 on the first, nothing on the second. You could do 10 on the first, 100 on the second. It doesn't matter. As long as you change the whole equation. Yep. Okay, so now I'm looking at these two, right? 15x plus 8y equals 23, and 3x minus 2y equals 1. Already I know there's no variable that's completely by itself, so it's not like there's an easy one to pick. So just pick one variable and solve for it. Pick. The x in the second one. So I would get 3x equals, I'm going to add the 2y. 1 plus 2y, or 2y plus 1, order there doesn't matter. And then I got to divide everything by 3. X equals 1 plus 2y over 3. I can split that, or I can keep it together. It doesn't matter. The benefit of keeping it together is if you look ahead, 15 is going to be, like 3 is going to divide into 15, so I can get rid of it. So now I'm taking this. I have to plug it into the equation I didn't use, so the first one in place of the x. So I get 15 times 1 plus 2y over 3 plus 8y equals 23. 3 goes into 15 5 times, and then I have to distribute that 5 to both the 1 and the 2y. So 5 plus 10y plus 8y equals 23. 5 plus 18y equals 23. Subtract the 5. 18y equals 18. Divide by 18. Y equals 1. That's the y coordinate of my solution. I'm going to take that and plug it back in. You can plug it back in anywhere you want since we already solved for x here. 1 plus 2 times 1 over 3. 1 plus 2 over 3. 3 over 3, which is also 1.
So when you find x, for whichever equation, you always plug that x back into the other one.
Correct.
And then
Like when you mean the expression part?
Yeah.
Yes.
And then when you find the y, just
When you find the value, when you found the first coordinate, you can plug it back into whatever you want. Mm-hmm.
So when it's plotting this as an answer, do we put it into a coordinate form?
Yep. I don't think there's spaces either. Yeah, there's no, it gives you the parentheses on some of them. Let me see, does it all? It actually gives you the parentheses. It just leaves the space between it. So it looks like this. And then you fill in this space. So you would just put 1, 1 on web assign. And no solution literally says the words no solution, all one word, all capital. But it says it in the instructions.
you couldn't have plugged in that y back into like 15x,
You can.
8y.
Yeah.
You just have to redo x.
Exactly. Yep. So this says use a graphing utility to verify. This is where, like, let's say you get to use your graphing utility on a standardized test. This is like one of those benefits to it is that any system of equation you can actually plug in. So I'm gonna, well, let me switch the view. I'm going to type these equations into my system, into my variables. Here's the catch with this one, is that these both have to be solved for y in order to plug them into my, right? Because this is y equals. So in order to plug them in, they have to be solved for y. So I take that one that I've solved for x doesn't help. I have to take this 15x plus 8y equals 23 and solve it for y. So 8y would equal 23 minus 15x divided by 8. When I type that in the calculator, it can be as messy as you want it to be. 23 minus 15x could be in the parentheses like that, divided by 8. So it doesn't have to be simplified, but it does have to be solved for y. 23 minus 15x, close my parentheses, divided by 8. That's going to be my first line. Then the second line, and I could have even done this with the decimals. It doesn't matter what you do it with, but if I take this one, 3x minus 2y equals 1. Solve it for y. Divide by negative 2. I could write it like just like that. 1 minus 3x divided by negative 2. But I got to group the numerator. 1 minus 3x divided by negative 2. The negative that's on the bottom, this guy has to be the negative. Enter. Now I hit graph. Mine does them in colors, so like if you look at your y equals, you'll see there's a color assigned to each one. That's how I know the difference between them. If I wanted to find where they intersect and it's not obvious, I say second, trace to get to the calc menu, and you go to 5 that says intersect. Hit enter on both curves. It says guess. I hit enter again and it brings me to the intersection, which is 1, 1. Yeah. Say that again. Right now, you're using it to just check the answer, but there may be times in which your equations are not ones you can solve easily, and so it might say use the graphing utility to find the answer. So all that did was check our answer. 1, 1 was where it intersected.
So you just used the same equation to find x and y?
Yep, but you had to solve for y.
How do you find the
No, you solve, like when you type it into the graphing utility, you have to solve for y. So both of these were solved for y. I went back to the beginning and I solved it for y.
How do you find the point?
You do second trace. Here, I'll do it on the So here we're solving it, and by solving by graphing, we mean graph by hand. It says graph each line. Where the lines intersect is the solution. That's what we just did. The two special cases with graphing are parallel lines and overlapping lines. If they are parallel, they will never intersect, and so our answer would be no solution. If they are the same equation, then it's all real numbers. All right, so it says solve the system by graphing. Okay, we're going to graph by hand. So if this was a question on a quiz or a test, you wouldn't have a handheld graphing utility for this. That's why I got to learn how to graph by hand. So I'm going to solve each of these for y. I'm going to put them into y equals mx plus b format. So I'd get negative 2y equals negative 3x plus 7. And then divide everything by negative 2. And I get y equals 3 halves x minus 7 halves. I'm going to have to graph it, so I'm going to convert that into a mixed number. So 3 halves x minus 3 and 1/2. That's just going to help me graph it because that's my b. So the goal is get it in y equals mx plus b. That's why I want the x to be the first term. So I'd start at negative 3 and 1/2 because that's the b, which is here.
Wait, sorry.
It's okay.
Wouldn't the 3 over 2 x be negative?
Yeah, but then, no, because you move it, so it's a negative when you move it, and then you divide by a negative, so it's positive. The slope from here is 3 over 2, so I go up 1, 2, 3 to the right, 2, and I plot a point, and I draw a line. If you want to draw, whoa, what did I just do? If you want to draw another point, that's fine too. So I could have gone up and up 3 to the right 2, or I could have gone down 3, 1, 2, 3 to the left 2, okay? Then I'm going to do the same thing with the second one. So I'm going to solve, so subtract the 6x. And I get negative 4y equals negative 6x plus 9. And then divide everything by negative 4. And I get y equals 3 halves x minus 9/4. Or 3 halves x minus 2 and 1/4. I would go graph that. 2 and 1/4 would be here. Slope 1, 2, 3 over 2. Or down 2, 3 over 2. What do we notice about 1, 2, 3 over 2? What do we notice about the slopes of these? They are the same, so these would be parallel. So what's my answer here? No solution. And WebAssign literally says, like, write the whole word. No solutions. I think it's no spaces, but it's in the instructions. If they cross, like they did on the graphing utility, we would just locate where they cross. We'd give the x and y axis, x and y coordinate. That's where they would cross. If they don't cross like this, then it's no solution. If they end up being the same line when you go to graph them, that's when it's all real numbers. Questions on that one? All right, example 5, solve the system graphically. The first one, x minus y equals negative 4. So I could get negative y equals negative x minus 4 and y equals x plus 4. And start at positive 4 and my slope is up 1 and left 1 or down 1 or up 1 and right 1 or down 1 and left 1. Doesn't matter which way you go. What do I notice about the second equation? It's a parabola, right? So this is no longer two lines. It's going to be a parabola and a line. So I want to solve for y still. I would get negative y equals negative x squared minus 2. Multiply everything by negative 1. Y equals x squared plus 2. So what do I know about this parabola based on its transformations? Oh.
What is the negative 1?
I multiplied everything by -1 to make the y negative. I mean, to make the y positive. What do you remember about these parabolas if it's a +2 after the function? It's up 2. So that at least gets me the vertex, right? So if I shift it up 2, I know it's here. I don't have exact points yet. Well, this is where the plugging in comes into play. So if I plug in, at least this is going to give me a roundabout. I know it's like that. So I think it looks like it will probably cross at -1. It will probably cross at +1, but I don't know yet. So I'm going to plug in. So for the parabolas, you need exact points because you need to know where they're going to overlap. If I plug in -1 to here, y would equal -1 squared plus 2. I get 1 plus 2, which is 3. 1, 3 is a coordinate point that's on my line. So there's my first interaction, or my first intersection. -1, 3.
So you just chose a random.
Sort of random. I knew where it was at least going to point, so it looked like it was going to cross there.
Yeah. Thank you.
You're welcome. Daniel, what was yours? Okay. Now I know this is symmetric, so if I went up 1 and left 1, I would have to go up 1 and right 1. That's my other point. That's not a point of intersection, right? So don't even waste my time plugging in 1. Now I'm going to plug in, so this would have been 1. This would have been 2. If I plug in 2, I get 2 squared plus 2, 4 plus 2, which is 6. 2, 6 is a coordinate point on the line, which means that's the other intersection. I knew it wasn't 1, right? Because if it's symmetric on the left, I went up 1 and to the left 1, I would have to do the right, and it would be here, and that's definitely not crossing the line. So then the next one is what I tried. If I plugged in 1, I would have gotten 3, and that's not a coordinate point that is on the line. So if I had graphed this using that handheld graph, x plus 4 and x squared plus 2. I had to plug in a point to see if it worked. Well, I plugged in -1 and I plugged in 2. Yeah. It doesn't matter where they are as long as they intersect with the line. Graphing utility. Oh. Okay. Let's say I want to, and it's a parabola this time, right? There's going to be 2 points of intersection. So when it says second trace and I go to intersect, you got to move it so it's near whichever one it is. So if I want to do first curve, let's say I want to figure out that one on the right. I'm on the blue right now. Anywhere over here is fine. And then the red, where's the red cursor? I can't even see it. Anywhere on that red that's near the blue. So I want to be closer to that intersection than the one on the other side. I hit enter and guess. It's going to bring me to the one on the right, which is that 2, 6. If I do it again, second trace, 5 for intersect, I would this time want to move towards the other one. So you got to be closer to the one on the left than you are to the one on the right. Second curve, enter, and it's going to bring you to that one as well. Okay, so in order to get both intersections, you literally have to move that little cursor closer to the intersection you're trying to find than the other one, and it will bring you directly to it. But again, that's just a check. Questions? Yep.
So on the calculator, you have to put the little cursor like in between.
It just has to be closer, like, so if you wanted to pick the one on the right, it has to be closer to the one on the right than it is to the left, and if you want to pick the one on the left, it's got to be closer to the one on the left than it is to the right. Yeah. Okay, so this one, notice direction says, solve the system using substitution and then use the graphing utility to verify. So we're going to first do the work for substitution, and then we would use the graphing calculator just to make sure we're right, okay? So I've got x minus y equals 0, x to the third, sorry, minus y equals 0. So pick a variable, solve for it. Y, which one?
The first one.
The first one. Okay, so we would move the y to the other side. I get x equals y. And then we're going to take, you're saying solve for y, so take the x and plug it in the place of the y. So I'd get x to the third minus x equals 0. You could have done the same thing for the y's. It would have been the same.
Wait, but I thought we were
technically this is solved for both. This one's weird, right? We solved for y, so then we plugged in the place of the y.
But you can't plug the y in place of the x.
For this one, you actually can because it's the same. X equals y, y equals x.
So if you plugged in y squared minus y, it's fine.
Y to the third minus y. Yes,
Yeah.
yeah. I could have said x equals y, and then in place of the x, I could have put the y. So it would have been y to the third minus y.
Yeah, okay.
You could do it either way.
Okay.
Yep. So let's go with the x's. X to the third minus x equals 0. How do I solve that?
X and then x squared minus 1.
Good. And then what? X equals 0. And x squared minus 1 equals 0, right? So I get x equals 0. That's one x value. X squared equals 1. And x would equal plus and minus the square root of 1, which means x equals plus and minus 1. I got 1 and I got negative 1. So there's 3 intersections on this graph. It's a cubic function, so when you see it, will make sense. But there are 3 intersections here. Those are all the x values. I got to find all the y values, but every x is the same thing as y. So if x equals 0, then y equals 0. If x equals 1, then y equals 1. If x equals negative 1, y equals negative 1.
Oh, because they're the same.
They're the same. Now plot it. So I'm going to show you how to do it on the graphing utility as well, just so that you can see, like on the app, so that you can see both. All right, so there's it on the graphing utility. So if your question, let's say homework says to use the graphing utility to verify, I don't need the picture. The picture is there for you to check your answer. If it says graph something and answer a question based on it, then you have to include the graph as part of your answer. But if it's just to verify, you don't need it. All right, this one says use a graphing utility to approximate all the points of intersection on the graphs of the graphs equations in the system and then round to 3 decimal places. Verify by checking your results in the original system. So this is where you would just go straight up to the graphing utility. You don't have to solve this using substitution. You're literally going to go to your graphing utility. So I just did it on the graphing app so that you could see both. But when you type in the 2 equations and you double tap the screen, you get the thing that says intersection. You tap the little dot right there where they cross, and it's going to give you the x value is 2.25. The y value for both should be the same, is 5.5. It says verify by checking your results in the original equation. So if I had taken these, for time purposes I won't, but if I took these and plugged them in here, 5.5 should equal the square root of 2.25 plus 4. I would type that in the calculator and you would see the answer. And then I would do 5.5 equals 2 times 2.25 plus 1. You're going to get 5.5 equals 4.5 plus 1, and 5.5 equals 5.5. So it's just showing you that the solutions would work both ways. On the graph, if you get them from the graph, you should plug them in, get them. If you get them from the equations and then you verify with the graph, they should both work. Yep.
Can you do that on the actual?
Okay, the rest is literally word problem application of systems of equations. So you're going to get information, you're going to set up a systems of equation, you're going to solve it. These are interest problems. So the interest problem says something along the lines in the information that you're given. You're going to get 2 different accounts producing 2 different types of interest, like certain percent and certain percent. Could be 2 savings accounts, could be 2 credit card accounts, could be 2 mortgages, whatever it is. You get an amount of money and then a percent earned on the amount of money and the relationship between them. So this says you're given the yearly interest earned from a total of $12,000 invested in 2 funds, paying a given rate of simple interest, which means not PERT. This is just the money invested times the percent it's invested in. That's what simple interest means. You're going to write and solve the systems of equation to find the amount invested at each rate. So the total interest is going to equal the amount invested times the rate in decimal form. Okay, we can't use percents. From these, we should be able to set up 2 systems, or 2 equations, the system. So here I've got the amount of interest earned from both accounts is $500. I've got X amount for rate 1. At the 3%, we're going to say it's X. At the Y, we're going to say it's 5%. So you want to establish your two different amounts. So X amount of money is earning 3%. What is 3% in decimal form? 0.03. Y amount of money is earning 5%. What's 5% in decimal?
0.05.
So that's equation 1. That's the interest earned. What other piece of information did they give me that I haven't used yet? The 12,000. So that means what plus what is 12,000? X plus Y. The total amount invested at each is 12,000. From here, I can multiply this by 100 to get rid of my decimals. I'd get 5 with 4 zeros behind it equals 3x plus 5x, plus 5y. So I multiplied by 100 to get rid of the decimals. And now I can solve this system. So far, we've reviewed substitution, so that's the method I'm going to use. Eventually, I would say this is easier elimination, but we're going to use substitution. So I'm going to solve one of these equations for one of the variables. The top is easier. It doesn't matter which one, but let's just say x would equal 12,000 minus y. I take this, I'll plug it in here. 50,000 equals 3 times 12,000 minus y plus 5y. Distribute 50,000 equals 36,000 minus 3y plus 5y. 50,000 equals 36,000 plus 2y. Subtract the 36,000, 14,000 equals 2y. Divide by 2, and y is 7,000. So that y was my 5%. We've invested $7,000 at 5%. If it's 12,000 total, how much was invested at 3%? 5,000.
So you don't need, like,
You don't have to. You can. You get the same answer, but sometimes it's just easy like that. So when you're dealing with interest, there's got to be an amount invested times the interest you're earning equals the interest, and then there will be some relationship between them.
So it's 7,000 times 5?
No, well, if I wanted to check my answer, that's what I would do. 7,000 times 5% plus 5,000 times 3%. But it's how much money is invested at each rate. So it's 7,000 at, say, 12,000 minus, because it said they were both right, 12 was invested, the total was 12. So once we found the 7, we just subtracted it from it. It's the same thing as plugging it in here.
No, I'm lost. I don't know how you got the 5,000.
So the break-even analysis is used like by companies to figure out how much to charge for something, right? So a break-even means I don't want to be losing money anymore. At what point does my revenue equal my cost? That's your break-even, okay? So sometimes you'll have to set up your cost function and your revenue function like it will tell you. It costs you so much money to start up, plus each unit costs blank amount. And then you would form something called a cost function, which looks like this. This one's already given to you. That's $8,650 per unit plus $2,500 a unit. So this costs a lot of money. Whatever this is costs a lot of money, okay? That's your set rate plus how much it costs to produce each unit. C for cost. Then you have your revenue, how much money you are charging per item. So how much money you're bringing in here, which in this case is $9,950 times each unit. So whatever amount of units would cost normally $10,000, something like that, okay? Now the break-even point is literally just when these are equal. So you can take one and substitute it in for the other and solve. These are like the easiest problems that people get hung up on because they don't practice it, and all you have to do is set them equal to each other. So I'm looking for when my C equals my X. I set this equal to each other. I'm sorry, where my C equals my R. And then I would subtract 8650 X from both sides. And I'd get 250,000 equals 1,300. And then divide both sides by 1,300. Cross through, and 2,500 divided by 13 is 192.3 units. Now, what did it say to round to? Which hopefully should make sense, because can you sell 0.3 of an item? No, but here's the catch with break even. If I round it down, have I broken even? No. So even though by laws of rounding, I'm supposed to round this number down, with break even, we always round up. So I need to sell 193 units in order to break even on this. If I sell 192, I have not broken even yet. It's still in the red.
So from the one like C equals, what are both those numbers?
This would be your set rate. So like this would be like a startup, or how much money you have to invest, just a startup. Whatever the set amount of money or set investment, I don't know, not rate, investment. Like you want to start mowing your neighbor's yard. It's going to cost you this amount of money to buy the equipment, right? And then, well, that's a bad example because that's a service, not a, ignore that. Okay, you want to start selling, I don't know, what do you want to sell in your life, Helen? I don't know. Let's start selling Apple pencils, and you have bootlegged some sort of equipment that you can make them even though you're not an Apple distributor, okay? So whatever that illegal equipment is that you're making costs you, that's a lot of money, but $250,000, right? That's your initial front setup. Then each unit costs you $8,650. These are very expensive Apple pencils, but you get the point, right? That's your cost function. But you're able to sell them for $9,950 a unit. That's how much, that's where that number comes from. And the goal is to get them equal to each other, and then obviously figure out where that break-even point happens. The other kinds of questions, you're going to get a mixed bag as far as word problems go, but the other kinds of questions can be like geometric related. So this is another love of standardized tests. The perimeter of a rectangle is 30 meters and its length is 3 meters greater than its width. Find the dimensions of the rectangle using a system of equations. There is actually a way to do this without a system of equations, but we're going to set it up. First of all, we need to know the back information on the perimeter of a rectangle. How do we find the perimeter of a rectangle? Add all the sides together, or what's the formula? Twice the length plus twice the width. I'm very proud of the two of you that remember geometry. The rest of you, I fear for your standardized testing skills. And it is Friday, yeah. All right, then it says that is 30 meters. So 30 equals 2L plus 2W. So my two variables are length and width. Then it says the length is 3 meters greater than the width. What does that look like in equation form?
This would be L is equal to W plus 3.
Good. Now you've got a systems of equation. Two variables, two equations, and it is easily set up for substitution, which is very convenient because that's what we need to practice. I'm going to take what L equals, and I literally plug it in the place of the L. So 30 equals 2 times W plus 3 plus 2W. Distribute here. $30 equals 4W plus 6. Subtract the 6. Divide by 4. My width is 6. What's the unit? Meters. So the width equals 6 meters. And then the length is the width plus 3. So 6 plus 3. If it says dimensions, it's just 6 by 9. Just like that, meters. Okay? You don't have to put which one is which. Questions? You're going to get a whole bunch of different kinds of systems. You just got to be able, like word problems, you got to be able to set them up, solve them.